opportunity here to take a closer look at graphing with transformations. So what I have here is a graph that should be helpful for us as we work through this. This is the square root function. Now, these transformations, and I'll demo this in a little bit, are going to behave the same way regardless of which function we're starting with, but this will be the best one to visualize things. So what can we do? Well, first thing we can do is we can add or subtract some quantity outside the operation. If this were happening to the original function, this would be, plus 4, right, outside that square root. So let's see what it looks like when we take a look at a graph like that. Well, when that k value is positive, it is a vertical shift. You can see as I move my k value, you can see the vertex of this square root function move along with it. And when that k value becomes negative, we're really subtracting 2. And now we can see that vertex, which used to be at 0, 0, is now at 0, -2. That k value, that number outside the operation, and that could be a square root, that could be, let's see, if we were to change this to x squared, we can still see that the original is in black and white, and the transformed is still being shifted down 2 units. Now let's go back to our square root. There we go. Now, how else can we move our graph? Well, the other thing we can do is we can add or subtract inside the operation. When we are adding and subtracting inside the operation, everything is backwards as compared to what we would think. So if we were to subtract 1, for example, that's actually going to move our graph to the right. Right, just to visualize this, right, this is inside the square root x minus 1. And you can see as that number gets larger, so too does the shift. When that number becomes negative, it really is going to be a positive number, right? -4, right? Because we usually use a negative value in here. The big idea, whenever we're shifting left or right, we always move in the opposite direction of the sign of which we see inside the parentheses or the absolute value or the square root. So H affects our horizontal shift. It's a shift in the opposite direction of the sign. We can also multiply. On this first particular problem, we're going to multiply outside the operation. This is going to be where we get our vertical stretch and compression factor. As you can see, when A gets bigger, our graph gets taller, right? If I have an A value of 3, my original has the point 1, 1. Our new function has the point 1, 3. Our original had the point 4, 2. Our new function has the point 4, 6. The y coordinates are 3 times as big as they normally were. So we have a vertical stretch when this number in front of the operation, outside of what's being square rooted or squared or cubed or absolute valued, that value will be a stretch. And if that number is less than 1, you can see on our graph here, that's going to be a vertical compression, right? This would be a vertical compression by 3/5, this by 1/2. Why is it 1/2? What used to happen when y is 2 now happens where y is 1. So multiplying will stretch our graph. If we multiply outside the operation, it's going to stretch our graph vertically. If we multiply inside the operation, and just pay attention to the way this is shown, it's 1 over b, the reciprocal of b. So when this b value is, let me highlight this, when this b value is 2.5, right, this represents a horizontal stretch because this 3 is really the denominator of what's being inside. What we're multiplying by here is 1/3. That 1/3 leads us to a horizontal stretch by 3. We have a horizontal compression when that value inside the operation is greater than 1, right? 1 over, say, 0.5 is the same as 2. This would be a horizontal compression by 1/2. What used to happen when x is 4, now happens when x is 2. The last type of transformations that we will see is when our a or b values become negative. So if our b value becomes negative, you can see that is a reflection across the y-axis. Let's move b back to b1 and get rid of it. And if we have an a value that's negative, we can see that it will reflect over the x-axis. I kind of like this Desmos representation. You can see kind of as things change, right? This a value is stretching my y coordinates, and as it gets smaller, it's compressing my y coordinates closer and closer to the x-axis. Eventually, right, we hit 0, and it's not a function. But then once we become negative, our stretch has now moved across to the other side of the axis, and we see a similar quality. Now let's move that back to 1. Right, the same idea happens here. Our stretch and compression really moves its way over the y-axis once we become negative. So just to simplify things, whenever we are adding or subtracting, as we were, let's see if I can highlight, here and here, let's get rid of that green graph. These are added values that will only move us up and down, or right and left. If we were to operate on our original function, if this were a -2, that's going to move us 2 to the right, and a +4, that's going to move us 4 up. We now have a vertex of 2, 4. If we were to stretch this by a factor of 2, our graph is now twice as tall as it previously was. So multiplying will stretch and compress our graph. Multiplying by a number greater than 1 outside the operation will stretch, and multiplying by a number less than 1 inside the operation will horizontally stretch. Negative values will also cause reflections. Inside the operation, the reflection will go over the y-axis, and outside the operation, it goes over the x.